All right, welcome back to our beautiful track about architecture and DevOps. I hope you had some very good meal for your lunch break. With me is now Viktor Farcic from Upbound, and he is talking about the future, and this is above the clouds. Victor, the stage is yours.
Thank you. Okay, let me share my screen. There we go. Almost. Okay, cool. So, there we go. The screen, right? So, I want to talk about where I believe we are going, given where we are. My name is Viktor. I work for Upbound. This is how I look like when you ask me questions. Kidding. Please do. Interrupt me at any moment with questions. I would like to make this as interactive as possible. I will try to be short. I will try to go fast so that I have as much time as possible for discussion, for questions. As I mentioned, I work for Upbound. I'm in different groups: CD Foundation, Google Developers, Docker Captains. I've wrote some books. Doesn't matter. What does matter is that I'm going to talk about where we are and where we are going. And to get where we are going, I'm going to go a bit into the past because I believe that's important for the discussion. Because if you want to understand where we're going, we need to understand where we started, right? So, long time ago, when I was still very young, and some people still are in that phase. Most of what we did was in our own data centers. We had bare metal servers in our own data centers, and that was uh, kind of miserable time, at least from this perspective. If you're young, if you haven't lived through what we did 30 years ago, then you're kind of lucky. Mainly because you're young, but also because you haven't experienced that. Anyways, so we moved from long time ago when we had our own data centers into very different way how we operate our systems. We got virtual machines, we got services, we got APIs, we got control planes. Even though most people do not know that they are using control planes all the time, they are. And we moved eventually, still a while ago, into clouds, right? And clouds can be, just to clarify, can be private cloud as well. It doesn't have to be AWS or something like that. Anyways, so today that's still in the past, right? Today we are trying really to move above clouds. I will explain later why I'm saying that. Um, for now, the important thing to understand is that almost everybody, and you will see why later, is multi-cloud, right? Right now, most of you listening are using more than one cloud service, almost certainly, or to be more precise, services from more than one cloud vendor, whether you know it or not. Now, let's go back to the beginning, right? What was happening like 20, 30 years ago? Bare metal on prem, meaning that you all had, if you lived in that time or worked in that time, we all had servers, physical machines. When we need something, what was happening? We would order machines and we would wait for months, and they would come, and then something would happen, something would be installed. Me as a developer at that time would go to ops person, whatever, or sysadmin, or whatever it was called at that time. I would say, hey, for this project we need this, and that person would order a machine. We would get the machine, and this would take months, right? It sounds unimaginable today when we speak about those things, but it would literally take months. I would need to think about servers and my needs before I even start thinking about the project itself. That's how long it took, right? And then if I make a mistake, I would send additional requests to ops people, and I would get additional servers, right? Whatever I need, if I can afford it, I would get, as long as I had enough patience to wait for that something to happen. Again, months. And at that time, basically, we had machines, and most of the things we were doing is by SSHing into a machine. So either ops person or a developer or somebody else, whatever you need to be done, whatever you need to have, you would SSH into one machine, do your stuff, whatever the stuff is, install application, put binaries, configure it, and so on and so forth. And then you would move to a second server, third server, fourth server, fifth server, and so on and so forth. Very slow, very tedious, and very error prone, because there was no guarantee really that if you need 5 servers that are exactly the same, that you would ever get 5 servers that are exactly the same, because most of the work was manual or through some sorts of scripts, but scripts were never really good for those things, simply because it was very hard at that time to make scripts be aware of the current state and do what is missing to converge the two states. They would just execute literal commands that we said. You could have some if else statements, but that was complicated by itself, right? So at that time, we had static infrastructure. The most important quality in a good engineer was to be patient, right? That was more important than how good you are, because if you're not patient, you wanted to open a window and jump, because everything took a lot of time. We had no services, we had no APIs, at least not in sufficient quality and quantity. We had no control planes. Almost everything was SSH, and we were doing things one server at a time. Now, over time, we got virtual machines, right? Virtual machines which are now used virtually almost everywhere. I mean, that trend is actually now reversing. I think that we might be going off virtual machines, but that would be a separate subject. But all of a sudden, VMware and others came up with solutions how we can virtualize environments, and that was absolutely awesome. And the reason why that was absolutely awesome is because operators or sysadmins could reuse existing servers and say, hey, I have this capacity available for me. And then you tell me what you need, and I will give you a virtual machine, because I can actually fine tune what that is. Hey, you need this amount of memory, this amount of CPU. I do not need to give you the whole server. I can give you a part of it, right? It was faster to create as well, because ordering a new server, configuring a server is much more error prone, much slower than just spinning up a virtual machine. Now, at that time, we were still not leveraging the real advantages of virtual machines. We were still struggling with the concepts of immutability. We would still treat virtual machines as if they're not virtual, meaning that as if they're real servers. You get virtual machine maybe with all the operating system, and then you will still have to repeat all the steps from before. You SSH into those machines, you install what you need and stuff like that. At that time, we had really still trouble understanding the concepts behind immutability, behind creating virtual machines based on images that already contain everything that we have or everything that we need. Even and those concepts at that time were almost the same as what we know today as containers, um, except that it was hard to comprehend it, right? But technology existed how to treat virtual machines more or less as containers. So, long story short, operations were extremely happy with virtual machines because it gave them more flexibility, more freedom. But from developer perspective, not much changed, right? I still need to wait and still need to request something from somebody. I could not be in control of what I need, because my company did not allow me to be in control, or because I did not have services, I did not have APIs. I just had virtualized the same as before, just virtualized right now. And so, what did we get at that time? We got virtual machines that allowed us to create services whenever we want. It was still mutable at that time. It was great help for operations, not much different for everybody else. So it didn't improve much. It improved only for some people. And then we finally got cloud. Now, cloud in the past, when it emerged, from the very start, showed some qualities that were very hard to accomplish without cloud. We got APIs, meaning that whatever you need, you do not request it, you do not open a Jira ticket or send an email. You had an API that you can use to say, hey, this is what I need, give it to me, right? Or this is the change I want to apply to something, doesn't matter what it is. and then it all of a sudden it happened, right? We effectively replaced SSH with APIs. And more importantly than that, we got control planes. Today, when we talk about control planes, most people associate control planes with something like Kubernetes or Mesos or Docker Swarm or whatever you are or might be using. But actually, almost everything, especially in cloud, that was behind an API actually had behind that API a control plane. If you go to AWS, it looks like you're requesting a VM, and that's what you're doing through the API. But what you're effectively doing, what AWS is doing, is sending that information from that API to a control plane, and control plane had and still has extremely difficult task to figure out how to fulfill your desire together with desires of countless other people, companies, entities, and so on and so forth. And at that time, most of the cloud was limited to virtual machines and storage, right? So it wasn't much. It wasn't even close to what we had today. You get the virtual machine, you get storage, a bit of networking, and off you go. Still, it was absolutely amazing because all of a sudden, I, as a developer, let's say, could get things easily. I did not need to send a message, send a memo, send a fax to somebody to get it. And everything became highly dynamic, right? We finally, I would argue, some people would say that environments became dynamic with the emergence of VMs, but that's only partly true. What really, really made everything dynamic was cloud, simply because people behind AWS and later on Azure and Google and so on and so forth knew how to do that. They passed their internal experience into us as end users, right? Now, so before cloud, we had hardware. With cloud, we got services, we got APIs, we got control planes. Those are the fundamental shifts, fundamental changes into how we understood and how we operated and still operate our systems. Now, at that time, and still some people are saying, hey, actually I can do cloud myself. I can have my data center, I can set up things like AWS. And yes, you can do it. Was it worth it? Is it worth it? Probably not, because if you really try to replicate public cloud internally, that's a lot of work. And a lot of experience that you might or might not be having, right? Now, if we move to present tense, cloud evolved drastically. It's very different than what we had, I don't know, like 5 years ago, 10 years ago, something like that. Although now it's not anymore about virtual machines and then storage. I mean, those things are they're still there. What cloud now is about potentially everything, right? If you need a VM, you go and say, I need a virtual machine. You get the virtual machine. There you go. Off you go. Next. If you need a database, you get a database. If you need a repository, you get a repository, right? Git repository, GitHub, GitLab, whatever you're using. If you need storage, you get storage. If you need machine learning, you get machine learning. And all those things are, from the perspective of a user, services, right? It's all self-served. You do not need to go to anybody. You do not need to request anything from anybody. You do not need to see a human being ever, directly or indirectly. Everything we do now is exposed as a service. Doesn't matter how much that is a software or hardware or a combination of both. And all those things, no exceptions, with absolutely everybody, follow the same pattern. You have some services. Those services are accessible through APIs, and there are control planes that are making sure that things are happening, that these things are distributed, that they're running as they should, that they are fault tolerant, that things are happening, right? They're constantly monitoring the situation in data centers, massive data centers, and making sure that everything is always running, or as much as possible always running, right? The key here is a control plane. APIs are easy. Making sure that control planes are doing what you need to do, combined with the things that everybody else wants to do, that was always a real challenge. So today, what we have with cloud, we have services for absolutely everything. All the services are behind APIs, and all those services are always, no exception, managed by control planes. And now comes multi-cloud. right? And very often when I speak with people, they say, hey, that's not really, we are not multi-cloud. Uh, we are, majority of companies today are running everything in AWS or in Google Cloud or in Azure or in Alibaba or something like that. Somebody can easily argue that majority of companies are not multi-cloud in sense that they're not running in both AWS and Azure, for example. And that is kind of true. But that's a very narrow look at what cloud is. If you define cloud as services provided to me by somebody else, by some other entity, by some other company, or even some other team in my company, then cloud is not only and exclusively AWS, Google, Azure, Alibaba. Cloud would be Linode and DigitalOcean and quite a few others. And you might say, hey, I'm still running everything in AWS. But think about this. Are you using GitHub? Are you using Snyk? Are you using HashiCorp? Are you using Datadog, Grafana, Elastic? Almost certainly, almost everybody listening to this right now is using at least two of those. I mean, there are many others, right? So you might not be using literally two of those, but you are storing your stuff in GitHub. That's already one cloud. That's a cloud service, right? You might be running your VMs in AWS, again, cloud service. You might have your data stored. You might have your workloads scanned by Snyk, right? Or you might have your workloads in Datadog. If you do two of those, and you almost certainly do, you're a multi-cloud. And there are many, 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 many others, which I cannot fit in a single slide, right? So almost everybody today, even those that are claiming that everything is in their own data centers, most likely are using more than one cloud service from more than one cloud vendor, as long as we don't define cloud as being only AWS. Now, so almost everybody today is multi-cloud. Now, how cloud works, I already briefly explained that. For the majority of people, there is cloud, you request something, you get something. Majority, if not all, understand that there is an API. If you use Terraform, well, Terraform speaks to API of cloud service, cloud provider. If you use Ansible, again, the same story. If you use shell scripts, there is always an API, and there is always a hidden. You don't see it, but there is a control plane. Otherwise, something like AWS or Datadog or GitHub would never, never, ever be able to manage the workloads of all of us combined, right? So we request something from API. API passes that message to control plane, or to be more precise, more often than not, control plane is listening to API events and does something and makes sure that that something is always running. Now, so very simple. UI or CLI, U goes to API to control plane makes sure that something happens. Now, the problems with that approach, and assuming that my initial assumption that everybody's multi-cloud is correct, is that we are all of a sudden faced with many, many different, very different and very hard to combine things, meaning that we have dozens of APIs that we need to incorporate into our daily work. We have a bunch of control planes behind those APIs. They're all speaking with each other. They're all passing messages back and forth. We have different UIs. Each of those vendors that I mentioned before is going to give you a different user experience, whatever user interface, actually, whatever that user interface is, web browser, IDE, terminal, doesn't matter. They're all different. You're going to get different CLIs. And this is a huge mess, right? At least for people who are going beyond I only, and exclusively write code. And we need somehow to solve this, because the whole idea that we are using services for multiple vendors is not going to go away, right? We are not going back to the time where a huge company, had 100% of what they consume from one company, from IBM or something like that. That's not going to happen. We are going all using multiple applications from multiple different vendors, multiple services, and so on and so forth. And we need somehow to solve this problem. We need to figure out how we can all be focused on our individual specialties, on what we are focused on, while still giving everybody in a company a simpler experience than, hey, go and do something. Figure out all those UIs and APIs and CLI, and effectively manage your project like that. So the big problems that we are facing today is huge fragmentation, too many UI, CLI, APIs, and so on and so forth. It's getting harder and harder to manage, complicated to coordinate, hard to observe, because remember, your stuff is spread across many different places. And the most important potential problem is that almost all those that I mentioned before are actually not giving you the end service, are not giving you something meaningful. They're giving you building blocks. And that part is extremely important, because if you go, for example, to AWS, you cannot say, give me a Kubernetes cluster. No, you need to say, give me EKS and put some node group over there, or node pool, and give me few subnets, and give me a VPN and internet gateway and so on and so forth. And when I get all that, I get a cluster, as an example, right? And that makes perfect sense, because almost all vendors are trying to appeal to a very wide audience, right? And you cannot make something extremely opinionated from vendor side, because if you do that, then your user base shrinks drastically, right? Because all of a sudden, instead of everybody being your potential user, you transform yourself into only those who are actually doing things in the same way as I do are our potential customers. And that's simply not a good business for that type of business. So everybody gives us building blocks. Very few are giving us complete services that are doing exactly what we need. And as I said before, that's normal, because how can a vendor know what exactly you need, right? And how can those needs be fulfilled if everybody's needs are at least slightly different and not fully different? So where we are going right now is potentially, probably, moving what it's a tagline, moving above clouds, right? We need to figure out how we can make all that complexity invisible to majority of users in a company, right? And to do that, the only logical solution to that is to say, hey, there is a complexity. We are using different solutions from different vendors, from different services. But for everybody in my company, we should actually create ourselves, or somebody can create it for us, a universal API, so that user experience is simple, is unified. And we are going to create a universal control plane that is going to manage the workloads and stuff spread across many different clouds, many different providers, many different services. So that's basically what I will try to briefly show through a demo right now. And what I'm going to use today is Crossplane. I'm not trying right now today to show how Crossplane works and all the details. I just want to show a potential path forward, no matter whether that's Crossplane or some other solution, right? So think of this, the demo that follows, more as what we're trying to do in general as industry, rather than use Crossplane, right? I mean, you should be using Crossplane, but this is not a sales pitch, right? And by the way, the company behind Crossplane is where I work Upbound, so I'm slightly biased. So what we are going to do is figure out how we can unify all those different cloud services. How can we provide a universal API, a universal control plane, at least so that from user perspective, from a developer perspective, or tester perspective, or whomever's perspective it is, you have a single layer that does everything it needs to be done. And on top of that, I'm going to create some tailor-made services made specifically for my organization, tailor-made platform, shift left, so that everybody can be able to operate and get what they need uh, without spending 75 years trying to figure it out. So let me switch to my terminal and go briefly. I will try to go very fast through my demo, mostly because I want to open as to show to actually have as much time for discussion as possible. So let's start from the very beginning, right? The first thing we need is to be able to have a single place from where we manage all the resources located wherever, right? And today, based on the experience we have with industry today, technology, and so on and so forth, the only logical answer to be that single place today is obviously not my laptop. It is obviously not a virtual machine. It's a Kubernetes cluster that will act as a sort of management cluster for everything that I have in my organization. And to do that, I'm going to start with something very simple, and then I'm going to complicate it later. Let's say simplest possible scenario for now. Before going further, let's say that I want to create a virtual machine somewhere, and then I need to, in this case, I will do that in DigitalOcean. It can be anywhere else, depending on the providers that you choose. So I'm here going with semi-simple. It's not that simple, but we'll get there. They say, hey, I want something in DigitalOcean. I want to control what that something is. It's going to be called my virtual machine. It's going to be here. It's going to be this size. This is the image of my virtual machine. And that's about it, right? This is far from what I really want us to do, but I want to go step by step until we get there, right? So if I would like to get that virtual machine, and I'm right now connected to my management cluster, to my control plane of control planes, or universal API, or whatever we want to call it, I'm going to say, hey, I want to apply that file name, and that something is in here. And I'm telling my Kubernetes, here's the resource that defines something, and that something today, right now, happens to be a virtual machine somewhere else in DigitalOcean. It could be anything else. It's your job now to figure out what to do, how to do it, and so on and so forth. And I will move now to a different place because I will let my Kubernetes and DigitalOcean, actually, no, why not? Let me show you right away. Get managed. And if I list all the resources that are currently across plane, you don't see much, but what you will see is that it is already working, it is already communicating with DigitalOcean, and making sure that whatever I specified there is up and running in one of my end destinations, right? Now, creating that VM is too simple to be any significant because, hey, how hard it is to create a VM. So let's try to do something more complicated. Let's say that I want to have a Kubernetes cluster in AWS. And as I mentioned before, what does it mean to have a cluster in AWS? It means EKS node group, subnet, VPCs, VPNs, internet gateways, and so on and so forth. It means many things. Now, if I would approach this in the same way, if I would do the same similar thing to what I did with DigitalOcean, my YAML would probably be, I would have hundreds, maybe even thousands of lines of YAML. And that's fine if I'm an AWS expert, if I know it inside out. But if I'm somebody else in my organization, if I'm a developer, it would be either impossible for me to figure it all out myself, so I would need to rely on somebody else to do it for me and wait for that somebody else to do it, or I would really do a bad job or something like that. So instead of creating all those resources, what I'm going to do is show you a manifest, and imagine that there is an SRE, my company operator, who said, hey, you know what? Instead of you telling me what you want, I'm going to create a service that will be tailor-made, specific to the needs that we have in our company. And I will have many services, and one of those services will allow you to create and manage clusters yourself. You do not need to call me. You do not need to create and send me an email or whatever. All you have to do is to define something like this. And something like this says, hey, I have a completely new resource in my Kubernetes management cluster called cluster claim, right? This is not something that comes out of the box. This is not something that Crossplane provides. This is something that SRE in my company created for me. I mean, but I say for me, for everybody in my organization. And it's potentially relatively simple. It says, hey, I want something that we created and called cluster claim. I will use those labels to say that I want a cluster in AWS and I want that cluster to be EKS. If I would change this label to Azure, I would get a cluster in Azure. If I would change it to Google, I would get a cluster in Google. But what is significant here is that I do not need to know the details of everything. I need to know how something runs in AWS. But on the other hand, this is just as important or more important. This is not something that some other company created and defined for me. This is something that people in my company defined, and they know exactly what are my company's policies, what should be happening behind that. And I will show you what's happening behind that in a second. And I have a couple of parameters. Hey, I want medium-sized nodes. I do not know what is medium, whether that's T3 something something or something else in AWS, because we developers and somebody else like SREs agreed that it's enough to have small, medium, large, or whatever you choose, right? You are in complete control to define what this resource is. Now, if I would like to create a cluster, all I would have to do is to say, hey, and by the way, today I'm using kubectl. I would expect in real-world situation this to be done through GitOps. I would probably be pushing this YAML to a Git repository, but I was too lazy to set it up for this demo. So I'm doing it manually. And I'm going to say, hey, apply whatever is defined there, right? And remember, this is now very important. That YAML that you saw a minute ago was what, like 10, 15 lines of YAML, right? Extremely simple, extremely easy. Now, what is not so easy is what is happening behind the scenes, behind those 10 or 20, 15 lines of YAML, which, by the way, we call compositions in Crossplane. And I can show you what's actually happening. That service that was created for me by an SRE in my company results in this, right? I got behind the scenes, I got some roles, I got role policies, I got some objects, meaning that when that cluster is created, not only that I will get a cluster, I will get a production-ready cluster with some applications already installed in that cluster. I will get a cluster with some Helm charts applied. I will get a node group. I will get a cluster itself, route tables, subnets, VPCs, internet gateway, security group, right? All the things that majority of people, in best case, would be wasting too much time doing themselves, and yet it is tailor-made for what my company needs. This was not created, this composition was not created by any vendor. It's created by you, by me. And there is, by the way, there is this one that says Droplet. That's actually DigitalOcean one virtual machine that I created 15 minutes ago or something like that, and it's already ready. Now, you can say, this is too complicated. I do not care about all those things, and that's fair enough. If you don't care about all those things, you can just say, I do not care about those things. Show me the status of what I created, which is called cluster claim, right? So this thing is what I created, and it's Crossplane's job to figure out how to create everything else, all those 20, 30 what's or not resources. And it takes some 20 minutes to do it in AWS. I will not wait for that to finish because I do not have enough time. But what I will show you very, very briefly, how all this happened, right? How did I get to the point that I have something extremely simple and yet tailor-made for my own needs? And it consists actually, there are two steps, let's say, of what I did before I did this demo. The step number one, I had to create a definition, meaning that I created something that I call, where is it here? Composite cluster or cluster claim. This definition will create a completely new custom resource definition in Kubernetes, and it already did. And I'm saying I want to have a new resource type in my Kubernetes cluster. And that resource type should be based on Open API schema, should have some fields, whatever I want them to be. And in this case, ID and parameters have version, node size, and min node count. You're in control what that schema is, and Crossplane converts that schema and into custom resource definition, which is what I used. And then you can say, hey, I want to have different implementations of that new service, new interface. And one potential implementation, the one that I showed you, would be this one. This is my implementation of what it means, what should become out of that CRD or XRD as we call it. And here is where I defined all the stuff that you need to define no matter which tool you're using, right? A cluster. What else do I have? A node group, transformations. This is that medium becomes this in case of AWS, and so on and so forth. I had to define all this. This is tedious. This is complicated. This is horrible. But I do not want to pass the horrible to everybody else in my company. I use this. I define here what it means for me if somebody wants to create a cluster in AWS, and then that somebody can have a very, very, very simple service. And then we repeat. Then we do the same thing for other examples that I might be having in my company, right? Like for example, let's say that I want to enable people to deploy applications with the database, right? Now, what would it mean if you would need to deploy and manage application with the database? You would need to define Kubernetes deployment, ingress, service, maybe some service mesh, and so on and so forth. You would need, to define how the database itself, because application that depends on a database needs a database. And that could be database inside of a cluster. It could be RDS in AWS. If it's RDS in AWS, you would still need to define probably 5, 6, maybe 7 different components in AWS that would make it happen. Or you can do the same thing what I did with the cluster before. Say, hey, I, as a person who understands how all those things work, will give it to you as a service. And all you have to do is to say, hey, I want to define something new, completely new. I just invented it. APP claim is going to be an application, and that application will have a backend database. It will be a backend type of application. It could be frontend. It could be anything you define, and it will be having a database, and it will run locally on the same cluster where in this case Crossplane is, or it could be on some other cluster. Doesn't matter. And there are some parameters, like this is the image that I want to use for my application, right? Whatever we agreed collectively in my organization that we need. And then similarly, I'm going to define SQL claim, meaning, hey, I want a database. I do not know how databases work, how to set them up, but what I do know is that in this specific case, I want the database to be running in AWS, and I want it to be Postgres. And a few parameters like this is the version I want. Again, depends all on what we agreed on. And if you do that, again, the process is very simple. kubectl apply namespace is a team, file is this one, and I'm going to apply that, and then it will be up to Crossplane. Oh, I did not install the provider. I made a mistake. Imagine that this worked. I made a setup mistake. If I did not forget to install my SQL package, this would be working. And as a result, you would get all the resources that you need. Similarly, let me see one more example, last example for today. And then I will be open for questions. Let's say that you want to have a cluster that is ready for GitOps, meaning that it should have, let's say, Argo CD installed over there, Argo CD project configured, Argo CD application applied, and already pointing to some Git repository, so on and so forth. How can we make that simple? Well, yet another service. And this service in this case would be this one, right? Again, somebody created the composition that does all the heavy lifting, and all that I need to do as a developer say, I want GitOps with Argo CD. It could be GitOps with Flux, GitOps with whatever we do in my company. And this is the repository I want you to monitor and convert the desired state that is defined in that repository into the actual state running somewhere else. Apply that file, off we go. And all of a sudden, everything required for that cluster to be GitOps ready would be there. I think that I might be running out of time, so I will go back to. I don't know how much time I have. Probably like 5 minutes, maybe. I don't know. Let's see whether
3
there are any
minutes left
questions
for you.
Okay, I thought I was fast. I wasn't fast enough. Sorry for that.
Well, always great to see your presentations about Crossplane. Really love it. Shortly give the audience half a minute to drop in their questions. And or maybe
I don't know how to sing, so I cannot entertain people without questions.
Yeah, well, maybe you give the explanation so perfectly that the people do not have questions, which would be also great, at least from your presentation skills. But let's see if something comes in. But meanwhile, while we are waiting, I think one question which you always see or hear also from end users is like, how do you see currently the adoption of Crossplane throughout the providers? Is there some providers which are outstanding in all the adoption of it? Some which currently is heavy in development. How's the status?
Yeah, so there is adoption from different. Or I guess it's less adoption, but more development of providers. I guess your question was right. So that comes from three directions, right? One is what the core maintainers, including Upbound, are focused on, and that's why the first providers and the most developed providers are AWS, Azure, and Google, simply because that covers the widest range of people's needs, right? There should be providers for Alibaba and for Linode and DigitalOcean, and there are for some of them. But with big three, you cover the biggest surface. That's why we focused on those first. And now we are seeing slowly increased contributions outside from the core team. The other day, I was chatting with a few guys from DigitalOcean that are preparing the next release or their provider, and others. And right now, the last piece missing is, and we are in talks with different providers themselves, like AWS, Google, Linode, and so on and so forth, for them to invest themselves into developing providers. So it's we are not 100% there, but we are getting there slowly.
Awesome, very awesome to see. So Balázs had a statement and a question. He says, like, for him as a developer, he's not so often interested in provider itself or what he's using. He maybe is interested where it is running, like Europe or US. But beside that, he's not that deep into. So do you think that the clever orchestration of the resource will also be included in such universal control planes?
Yeah, so it's all about orchestration, and I would say actually that's one of the huge differences between tools that, let's say, infrastructure as code type of tools, which are basically doing things when we tell them to do, like, hey, do this. When in case of Crossplane, Kubernetes in general, not only Crossplane, it's all about letting control plane figure out and constantly monitor stuff and make sure that everything is up and running and all those things. And that simplifies a lot, many of the things, and removes quite a few headaches, right? There were two questions. I think I forgot the other one, or maybe not.
Yeah. Well, I think also the direction of the question is more like, do you think about to even abstract more the definition of the infrastructure, so that from developer I really don't need to pick all those details.
So we are not really, when I say we, Crossplane itself, we are not thinking about abstracting anything, because we believe that actually, if we start figuring out what would be the right level of abstraction, then that would be vendor opinionated, and it would likely not fit your needs. So instead of thinking what is the right level of abstraction, we are thinking more in the terms giving you the tools so that you can define what is the right level of abstraction for your company, right? You can create a service that requires 50 lines of YAML or 3 lines of YAML. We call it compositions. So it's intentionally focused on giving you tools to create abstractions rather than giving you abstractions themselves. I mean, there are some abstractions, but the end user abstractions, that's completely in your hands. You can make it be anything you want.
Awesome, perfect. And then we have another question from Verena, which is asking, which tool do you use for the YAML schemas you provide to the developers? Is there an own written tool, or where does it come from?
Oh, for that, you will need to ask me that question like a few weeks from now. Because we are releasing, we call it Marketplace. And so if you publish your configurations, compositions, actually, I can show that quickly, I think. We have it in very early stage. Let me see if I can share my screen. I need to be quick before they kick me out of this. So here we go. So anybody can publish here. And if we do, let's say the one that I showed you, here we go. I use Kubernetes, right? And if you publish it, you can get the list of all XRDs, like composite cluster. That's the one I used. And here is the auto-generated documentation with all the fields, whether it's required, and so on and so forth, right? So if somebody creates a composition, if it publishes it on Marketplace, then you get documentation out of the box. What is missing here is the ability to actually, and that's coming in a few weeks, to auto-generate, to have some fields that you fill in and you get YAML generated from that.
That looks awesome. Nice sneak peek. Looking forward to it.
Yeah.
All right. Fast check on the chat if there's something which we missed. No, it doesn't look like. So if there's any other question to Viktor, you can, I think, always reach out to him either on Twitter or on Slack. You will find him everywhere, and he's normally super responsive and happy to answer all of your questions. Thank you, Viktor. Was a pleasure as usual. Thanks for the great presentation. And I wish everyone else to have there comes the last question. Okay.
Yes.
Last few questions. Can you get other code snippets as well?
Code snippets? I'm not sure I understood.
So Valentinas, maybe you can add some more context to it. Otherwise, I need to close the session soon.
By the way, everybody, while thinking, give me more context. In like 3 and something minutes starts GitHub's panel, so you should come there. I'm just switching from one hit to another.
Maybe this is a question you can also throw into the GitHub's panel then.
Yeah, or ping me anytime. I always respond to everybody. So ping me anytime if I don't manage to respond right now, and I'll give you a hand.
All right, perfect. Then I will close the session here. Thank you again. Have a great day, and Soonish, have a great weekend. Bye-bye.
Cheers, everyone.